Welcome back to the channel, guys. Now today I'm bringing you the essential skills that you need in year 4 to be very successful in maths. If you can gain these skills by the end of your year 4 experience, you are a good mathematician. If you are struggling on any of them, well, that's why we're here, okay? We are going to plug those gaps. We are going to get you confident with everything you need to know in year 4. Okay, so what have we got? We're going to start with addition, then we're going to look at subtraction, we're going to then look at division, and then multiplication. These are our 4 staples, the 4 corners of any of our maths, and we really need to be really secure with these. After that, we're going to look a little bit deeper. We're going to look at adding and subtracting fractions and adding and subtracting decimal numbers, and then we're going to finish the lesson today off with polygons. Okay, so a lot going on, but we are here to help you, and this is going to be your essential guide to all things to know from year 4. Enjoy! Okay, before we can do anything, what is a multi-digit? Well, a multi-digit is any number that's got more than one digit place. So 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all single digit numbers. Anything above that, 10, 11, 12, all multi-digit. The number 19, double digit. We've got a 1 and a 9. A 9 in our units, a 1 in our tens. If we look at a great big number, 25,423, that's a 5-digit number because we've got 5 digits going along our place value chart. Okay, so with that in mind, let's move on. Our first question, 333 and 651. Now we are going to be perfect mathematicians today, and we're going to set our work out beautifully to avoid making any small mistakes. So the first thing we always do when looking at anything in column method, we always set out our work neatly. So let's do it. Units, tens and hundreds, put our equals bar across, our add sign for good measure to remind ourselves we are adding today, and we are good to go. Now, if any of you have watched any of my other videos, I think it's a great tip to bring this top bar down because we are going to be using that column potentially, that row potentially later. But wait! Does it matter which way round we put these numbers in our question? If we add 333 to 621, do we get the same as adding 621 to 333? Let's pause a second and let's look at it in this scenario. If I have 11 add 4, we get 15. I can represent it here with these images. If I switch these around and add 4 add 11, I still get 15. And that is because addition is commutative. It doesn't matter which way around we put our question, we're going to get the same answer. Let's go back. Okay, so we are ready to begin. Where do we begin? Well, we always start at our smallest value. And in this case, we've got a 3 and a 1 in our units column. So we are going to use our basic addition facts, and we're going to simply add them up. 3 add 1 is 4, so we just drop it into our equals bar. 4 units. Next, we've got 3 and a 2. 3 tens adding to 2 tens. A 30 add a 20 gives us 5 tens. Okay, good. Our tens column complete. Last but not least, we go into our hundreds column where we've got a 3 representing 300 and a 6 representing 600. Add the two together, we have 9 to complete our answer. Drag it up to the top. So 333 add 621 is 954. Easy, yes? Well, the observant ones will see a little green chili in the corner. This was a very mild question. Stage 1, I like to call it, or a green chili challenge. Okay, so let's have a look now at a yellow chili challenge. Let's see how this can get a little bit harder, okay? Let's have a look at the number 434 at 881. Now, same thing, we're gonna lay out our columns exactly as we should, put all our things in place, our units, tens and hundreds, our addition sign, and our equals bar, okay? Perfect, we are looking good. Remember, let's drop that bar down so that it gives us that spare row. We're gonna see how we're gonna use it in this question, okay? Where do we start? Well, we know now we start in our units column. We always start in our smallest value whenever we're doing any form of column work, addition, subtraction, multiplication, anything like that. We always start with our smallest value. So here we go. Let's start with our smallest value, our units. Adding 4 to 1 equals 5. No, nothing difficult there. Same as stage 1, same as our green chili challenge. Next question, 3 add 8. Okay, we have 3 and 8. 3 add 8 is 11. So we have a difference here. If we were to put 11 straight into our answer bar, we would be taking the place of our hundreds already, and we haven't added our hundreds yet. So we need to think about what this all represents and what we're going to do with this number. So we've got 11 tens, or we could look at it as 110 as the answer to this bit of our question. So we're going to use what we know of place value, that we haven't yet added our hundreds yet, and we're going to add this 1 into that column in that spare row, waiting for our hundreds question, okay? Which means we're going to add our 110 in our tens column in our answer section. But we haven't yet done our hundreds, so we're going to put this 100 up there, okay, waiting. Now we can answer our hundreds. I've got a 4, an 8 and a 1. Add them all together, gives me 13. So again, gives me a 2-digit answer. But different again, we have no further question. We don't have a 1,000 column ready, so we can just put our full answer in there. Put the 13 straight into our answer. A 1 in our 1,000, a 3 in our 100, leaves us with a grand total of 1,315. The answer to 434 add 881 is 1,315. This is called regrouping or bridging, depending on where in the world you're from. It means the same thing. We are just moving our number digits into the next column when we need to. We understand that if we were to add an 8 and a 7, we get 15, which is a 10 and a 5. So we can move that 10 into the next column waiting for us, okay? So very straightforward. It just takes a little bit of thinking. If you are struggling with it and you think, whoa, this is brand new to me, I've never seen anything like this before, rewind the video, have a little look at this question one more time, okay, before we move on to our red chili challenge. Okay, red chili challenge. Now you might be thinking, Mr. Maths Hero, this looks easy. This looks just like a stage 2 question, but it's not. We have got different amounts of digits in our question. We've got 962, which is a 3-digit number, and we have got 89, which is a 2-digit number. Now I cannot tell you how many times I have seen this mistake where children or adults even put these in the wrong column. So we need to understand place value again. You are going to get sick of me saying place value, but it is very, very important. So we need to understand what the value of these numbers are and where to put them. If I was to put my numbers over here and line them up like this, I have changed the whole value of our 89. And I have actually turned our number, using our placeholder here to represent where we've left a gap, we've turned it into 890. We've completely changed the question, so we are going to obviously get the wrong answer. So, what does our number represent? 89 is 8 tens, 9 units. Let's just put it in like that. 9 units, 8 tens. We know we're not going to make any mistakes. Now, we do have a gap here. We can put a placeholder, or you can leave a gap. It's up to you if you know that that's a gap there, or if you know that there's a 0 representing there, it doesn't change the value. Whichever you're more comfortable with is fine by me, okay? I'm going to put this little half 0 there so you can see it there or not there. Okay, let's start again. Same as before, we're going to start our units column. 2 add 9 is 11. 1 unit, 110, waiting for us for that next question. Tens column, a 6 and an 8 plus this 1 equals 15. Remember, 5 in our tens column, 1 now goes into our hundreds column. Looking at our hundreds column, I've got 9 and a 1. 9 and 1 equals 10. I've got no further questions to ask, so we just write the 10 straight in there. 1051, 1051. Okay, a few little differences there. We had 2 bridging or 2 groupings in a row, and we had this placeholder to consider and not make a mistake by putting things in the wrong line. This is about as hard as it's going to get. Red chili challenge. If you can do this, you can pretty much master column addition with multi-digit numbers, okay? And that's great. Right, if you are up for it, I have got a mega challenge here for you. This is a really hard question, and this is as hard as it could possibly get. Now I've got 3 numbers here. That's a little bit different, but it's not harder. It just means we've got 1 extra row to add up. Okay, so have a little go at that. If you need to, press pause. I'm going to flash the answer up in 5, 4, 3, 2, 1. Answer. Okay, so 4,211 add 901 add 591 equals 5,703. So I had to squint. I wrote that really small on the wall over there. I couldn't remember it. Okay, well done. If you got that right, you have mastered this lesson. Well done. Very, very well done, and I'm proud of you all. Okay, so as always, I'm going to tell you where your journey is going to take you, where your learning journey is going to take you, what is coming next, your next step. Okay, today we have been looking at whole numbers, a 3-digit number adding to a 2-digit number or another 3-digit number, but they are whole numbers. Your next step, you're going to be looking at decimals. So if you are there, if you've mastered this lesson and you want to move straight onto that, check out our video which is on our channel, or if you want to master this a little bit, practice this video a couple of times, go through some practice questions before you feel like you're ready to move on. Our videos are up on our website. We are putting new videos up all the time, so please like and subscribe. It really helps us out, guys, so I really appreciate that. Yeah, peace out. Your maths hero, gone. Okay, one very important thing we must discuss before we begin, and that is the law of commutativity. A horrible word, but it's not as hard as it sounds, okay? It just means, can we put our numbers in different places in our number sentence? So with addition and multiplication, those numbers and those operations are commutative. We can put them in any way. So if I show you this, if we have 15 add 6, I get 21. If I have 6 and 15, I also get 21, but I've moved the two numbers at the beginning around, okay? Now if we look at that in terms of subtraction, if I have 15 subtract 6, I get 9. But I can't get the same answer by moving my numbers around. They are not commutative. If I have 6 take away 15, 6 subtract 15, I get myself in all sorts of trouble we don't really want to talk about yet. But I know I don't get the same answer, okay? These numbers are not commutative. What does that mean? It means we've got to be ultra careful in the way we present our work and in our setup, okay? So let's have a look at a bigger number and what I'm talking about. So let's start at this. Let's have a look at a green chili challenge. Let's have a look at 149 subtract 26. So the question is saying, I've got 149 something. I could have vegetables, cars, money, whatever. 149 subtract 26. I'm subtracting 26 away from our original number 149. I can't manipulate that. I can't change the question. I can't say 26 subtract 149. That's not the same thing. So we need to be ultra careful in our layout. So first things first, let's arrange our columns. And you will know if you've seen any of my other videos, it's very important we put our units, our tens and our hundreds, our column titles at the top there to remind us to stay in our columns and be neat and organized. So hopefully we're pretty confident with our place value. If you're not, check out our place value videos, get all the information you need on that. But I know that I'm going to put my units in my units column, my 9 and my 6 and my units, I'm going to put them in my units column. But which way around do I put them? Do I put my 149 on top? Do I put my 26 on top? What do I do? The best tip I can give you, write it as you read it. It says 149, take away 26. So I'm going to write 149, subtract 26. Okay, I'm writing it as I read it. Some people might tell you, put the biggest number on top. I don't really like that piece of advice. There are questions which our answer needs to be negative, so we can't always put our bigger number on the top. We have to put our number on the top, which comes first. If it says 149 subtract 26, it means 149 subtract 26. So where are we going to begin? Well, you should know now we are always starting with our smallest value. In this case, we have units as our smallest value, so I'm going to start there. 9 subtract 6 gives me 3. Put my 3 in my answer row. Move across to our tens column. 4 subtract 2 gives me 2. 2 in my answer row. Move across, last time, look at my hundreds column. I've got 100, subtract, nothing there, or a 0, 0, 26. So 1 subtract nothing is 1. My answer, 123. 149 subtract 26, 123. Okay, don't forget to always pull your answer up to your number sentence to complete your question. Boom! Green chili challenge complete. Let's move on to red chili challenge. Red chili challenge. 123 subtract 15. Now you are thinking to yourself, I can read your mind, you are thinking, yo, that is just as easy as before. Well, let's check it out, okay? Let's put it back into our columns like we know how to now. 123, subtract 15. I've written it out perfectly, drawn my answer lines. Fantastic. Okay, now let's begin. I'm going to start at my smallest value, the units value. 3 subtract 5. Boom! Stop there. What does that mean? I've got 3. How am I possibly going to take away 5? Imagine you have 3 pencils in your hand. You can't take away 5. So what are you going to do? We need a method. We need a strategy. Okay, now this is where your understanding of place value is really essential. We should know that if we look next door, we have our tens column. So if we look in our tens column at this number 123, I have 2 tens. So I can look at my 2 tens as 2 tens, or I can look at it as a 20. And now I'm wanting to borrow or regroup from that number because my little weeny little 3 is not big enough to take my 5 away from. So I need to borrow something. I'm going to borrow from my neighbour next door. So we're going to go knocking. We're going to look at what we've got next door. I've got 2 tens. So I don't need 2 tens. I don't need the 20. I'm only going to borrow 1 10. Okay, 1 10 being a value of 10. So I'm going to borrow that, put it next to my 3. 10 and 3 equals 13. So my new value in my units column is actually 13. Now what I must remember to do at this point is I must remember that I've taken away one of the tens from my tens column. So this is no longer a 2, this is now a 1. Okay, good, I'm ready to continue. 13 subtract 5 is 8. Beautiful. Move across to my tens column. 2 subtract 1. No. 1 subtract 1. Remember, we took that digit away. We used that 10. So now I only have 1 10 remaining. 10, take away a 10, leaves me with no 10s. Good, moving over to my hundreds column. 1 subtract 0 again is 1, leaving me an answer of 108. Now let's remember, we always finish our number sentences, drag it up. 123 subtract 15 is 108. You've just done a red chili challenge. Okay, let's take this time. I'm going to throw 3 questions on here. I'd like you to stop, pause the video, take some time to have a look at these, see if you get them right. If you get them right, great. If you don't, go back, rewind the video and see where you might have made a small mistake. Okay, press pause. I'm going to come back to you in 5, 4, 3, 2, 1, boom. Okay, good, I'm back. So, throw the answers on the board. See how you got on. Hopefully you got them all right. If you did, great. You have just mastered this lesson. If not, don't sweat it. Go back, check it out, see where you might have made a mistake, correct it, and have another go. Okay? So let's just recap the important aspects of this lesson. Firstly, the layout is really important, not just to remember your column titles this time, but also the order you write your question. Remember, you write it as you read it. It's a good tip. Remember it. Next, presentation. Presentation. Okay, maths is all about organizing and being neat and avoiding those small mistakes. So make sure you're writing nice and neat in those columns. Last but not least, we start at our smallest value and we borrow from our next column along, our bigger value next to us, if we need to, okay? Guys, we have loads of videos on our channel all about maths. Check them out, like and subscribe for all of your maths needs. But for now, away! Maths hero gone. Right, before we can start, we need to think about what division actually means. Well, if I pull this question up, 12 divided by 3, we will learn that we can talk about division in 2 different ways. We can talk about it as sharing. If I have 12 lollipops, I can share them evenly between my 3 friends, giving them a total of 4 each. So 12 divided by 3, 12 shared by 3 is 4. Or I can look at it as grouping. How many groups of 3 are there in 12? That's a slightly more advanced level. Well, let's have a think. There's 1 group of 3 and 3, 2 groups of 3 and 6, 3 groups of 3 and 9, and 4 groups of 3 in 12. So we can look at it in 2 different ways, sharing and grouping. Now the reason that a question like 12 divided by 3 is quite straightforward is because 12 divided by 3 is part of a number family. 12 divided by 3 is 4, and 4 times 3 is 12. They are in the number families. But what happens if these questions get a little bit harder and they're not in number families? Let's have a question like 14 divided by 3. Well, we can try and share them. I've got my 14 lollipops and my 3 friends. I'm going to share them evenly. Gives them 4 each again with these 2 left over. Now these 2 left over are very important. I cannot share them evenly between my friends, so we have to leave it as a remainder. So 14 divided by 3 would be 4 remainder 2. If I try that with grouping, it would be the same thing. 3, 6, 9, 12, 4 even groups and 2 left over. Okay, 2 remaining. Okay, now that's pretty straightforward with small numbers. We can easily share our lollipops out. Might take a little while, but we can do it. And I can group because I know my times tables, okay? But what happens if we get a bigger question? Let's have a look at a green chili challenge. Let's have a look at 248 divided by 2. Now, I don't want to share out 248 lollipops. That's going to take me all day. And I don't want to have to go over my 2 times table all the way to 248. Again, that's going to take me a long time. So we need another method. This method is called the bus stop method. Now we call it the bus stop because it looks a little bit like a bus stop. Now we need to know, before we can start, we need to know where we are going to put our features, our parts of our question. So I'm going to put the dividend, which is the big number, the number we are trying to break up and share. I'm going to put that inside the bus stop. So I'm going to put my 248 inside my bus stop. Now I'm going to put my divisor on the outside, the small number, the one we are sharing the bigger number into. Okay, so my question now looks like this. How many 2s are there in 248? Okay, now before we can start actually solving this, let's think about our layout again. Let's put our hundreds, tens and units in to help us just understand what actually is happening, okay? Because we are going to start dividing along our bus stop, but I want us to understand exactly where our numbers are coming from and the actual real true value of our answer, okay? So, if we're going to look at this first part, 2 divided by 2, how many 2s are there in 2? Let's share it out. How many 2s are there in 2? Well, it's 1. We can share it evenly once. Okay, so how many 2s are there in 2? There are 1. Okay, but the question actually said, how many 2s are there in 200? And the answer is actually 100. Okay, so let's just keep that in the back of our minds just for our own understanding, okay? Now, the second part, how many 2s are there in 4? Well, if I share 4 between 2 people, I give them 2 each. So my answer for that section is 2. Last bit, how many 2s are there in 8? Well, the answer is 4, giving me a grand total of 124. Let's drag that back up to complete our question. 248 divided by 2 is 124. Great, green chili challenge, done. Okay, let's have a look where this can go. Let's have a look at a red chili challenge because they're not always going to be as easy as that. We could get complications as we're going to see now, okay? Let's have a look at 896 divided by 5. We're going to put our hundreds, tens and units up there just for our own understanding, but we're going to start in the same way. How many 5s are in 8? Okay, now let's go in our 5 times table. 5, 10. So we can't have 10. We've got one lot of 5, but then we've got 3 left over. Okay, let's have a look at that in sharing. If I have 8 and I try and share it evenly between 5, I give them all 1, but I've got 3 left over. Now I can't ignore this 3. I'm going to move it over into my next column and make my 9 a 39, okay? Because that 3 is actually worth 3 10s, okay? That's why it's good to understand our columns. Okay, let's look at my second part then. So how many 5s are there in 39? Let's go up in our 5 times table. 5, 10, 15, 20, 25, 30, 35, 40. I can't use 40 because it's over 39, so let's come back. 35 goes 7 times. So I'm going to put 7 at the top there. But what have I got remaining? I've got 4 remaining. Okay, so I'm going to bring that 4 over into my next column. Okay, last bit says how many 5s are there in 46? Again, let's do the same thing. 5, 10, 15, 20, 25, 30, 35, 40, 45. Can't go to 50, so I've got 9. What's the difference between 45 and 46? I've got 1 left over. So my answer is 179, remainder 1. 896 divided by 5 is 179, remainder 1. Okay, that's about as hard as short division you can go. That is a red chili challenge. So I'm going to put these 3 questions up on the board. Take your time, have a little go at them. Put your answers in the comment section below. Let's see if you get them right. If you do, fantastic, let's move on. If not, take a little bit of time on this video and make sure you fully understand it before moving into our next video. Okay, so I'm going to put the answers up in 5, 4, 3, 2, 1. Okay, answers on the board, fantastic. Well done if you got them right. As I say, let's move into our next video then. If not, rewind, go back, see where you might have made a mistake and correct yourself, okay? It's all about making sure you've got a great understanding before moving into our next step. So what is our next step? We have been looking at short division today. A multi-digit number divided by a single-digit number. Well, long division, our next step is going to be looking at a multi-digit number divided by a multi-digit number. Okay, so if you're ready for that, check out our next video. Thanks very much, guys. I hope you've learned something today. Like and subscribe to this channel. It's very, very helpful. Thank you very much. Away! One thing we need to learn before we can start is something called the commutative law. Now, horrible word, try and spell it. I don't think I can, but it's very important. So let's have a look at it, what it actually means. Let's have a look at this very, very basic multiplication question, 3 times 5. Now, we can see 3 times 5 can be represented by 3 lots of 5 marbles, okay? And we can know quite simply the answer is 15. But what happens if I move our question around and have 5 times 3, 5 lots of 3 marbles, and we can see it again here, we get the same answer. And that's because multiplication is commutative. The numbers are commutative. It doesn't matter which way around we put things, we are going to get to the same answer. That is very important when we come into working on harder questions. We need to understand that it doesn't matter which way around we do things, or we can always get the same answer as long as we multiply every part of our question. Okay, so let's have a look at a bigger number. I'm going to have a look at 243 multiplied by 5. Now, I don't want to have to draw out 243 circles and put 5 marbles in all of them. That's going to take us all week. So today we're going to look at another method. We're going to learn column method. And for those of you that know what it is, great. You might have seen it in your addition, you might have seen it in subtraction. But for those of you that haven't, stay tuned. We're going to look at it in multiplication. Okay guys, so we're going to have a little look at long method first. Now I strongly recommend doing this. You might not have seen this method before, but I strongly recommend this because it's a bit of a bridge between our previous method, our grid method, and our short method. It sort of breaks it sort of crosses that bridge. So we're going to drag our numbers down. I'm going to put my 2, my 4 and my 3, and I'm going to put my 5 underneath my 3. Why have I done that? Let's have a look. Let's set up everything else for a moment. You can see that my 243 can be represented with 3 units, 4 tens and 2 hundreds. My 5 is simply just 5 units. So I need them to be represented like that. I'm going to keep them in the relevant columns, the units column, my tens column and my hundreds column. And I can strongly recommend to make sure when you're doing questions like this, you put your units, your tens and your hundreds at the top there so that you can remind yourself that, because it's the most important thing. We can't change the value of numbers. Now I've got 3 steps because I've got a 3-digit number. If I had a 4-digit number or a 5-digit number, I'd have 4 steps or 5 steps. Or if I had a 2-digit number, I'd obviously have 2 steps. So the steps is just decided by how many numbers are in how many digits are in my numbers. So let's begin. Where to start? Well, we always start at our smallest value. So in this case, we're going to start with our 5 multiplied by our 3. We are partitioning our number. We're breaking it down into smaller, easier bite-sized chunks so that we can solve our question without the use of a calculator. So step 1, 5 times 3. Well, we know that's 5, 10, 15. So I'm going to put my 15 in step 1. Simple, but again, making sure I'm putting my correct use of my tens and my correct use of my columns. 1 in the tens column, 5 in the units column. Make sure you're doing that. The simplest mistakes that can be made are when people are putting their numbers in the wrong column or squishing it into little areas. Step 2, 5 times 4. Now it's not a 4, is it? Let's have a look at what column it's in, and this is where our understanding of place value and our column methods is very important. This is not a 4, this 4 is representing a 40. So the question is 5 times 40. Now, how are we going to solve that without a calculator? I don't personally like 5. I don't like 5 times 40. Hard question. We don't like hard questions. So I'm going to recognise my first placeholder. 5 times 40 is just 10 times bigger than saying 5 times 4. So if I drag my placeholder across, my answer is going to be 10 times bigger. 5 times 4, 20. Put that back in. 20 in the correct column gives me an answer of 200. Okay, 20, 10 times larger, 200. Okay, step 3. 5 times 2, but we now know it's not a 2, this is in our hundreds column, so it's 200. So the question says 5 times 200. Now we might not want to work out 5 times 200, so we can use our understanding of place value now and understand that 5 times 200 is 100 bigger than saying 5 times 2. Okay, so I'm going to put my 2 placeholders to represent 100 times bigger, put that across, and now I can just do 5 times 2. 5 times 2 is 10. I'm going to put my 0 in my hundreds column, and now I need a brand new column, my thousands column, for my 1, giving me an answer of 1000. 5 times 200, 1000. Okay, perfect. I've done all my steps, step 1, step 2, step 3. Finished? No, we've got a partitioned answer. I've got 3 answers because we broke our question into more manageable chunks. So now I've got 3 different answers that I need to bring back together for my final total. Okay, if you've never looked at column addition before, please have a look at our channel. You'll see a whole video for column addition if you need a little bit of help on that. If not, let's just fly through it. We know we're going to start with our smallest value, which is our units. Let's skip down our units column. You can see a 5, go down our tens column, 1, go down our hundreds column, 2, go down our thousand columns, 1, giving me an answer of 1215. Let's make sure we always finish our number sentence, flick it back up to the top. Beautiful, so my 243 times 5 equals 1215. Okay, great. Well done everybody. Now just interestingly guys, if we had a 4-digit number by a 1-digit number, we would just have a step 4. If we had a 5-digit number, we would just have a step 5, and we would understand our placeholders and things at that point. It doesn't make anything harder, it just makes it longer. We're still multiplying a multiple digit by a 1-digit number, okay? And that's the same in short method or in long method. Now it's your opportunity to have a little practice. I've got 3 questions here for you. I've got 143 times 4, I've got 546 times 6, and I've got 625 times 3. What I want you to do, pause the video now, try and use this method, this long method of multiplication, to solve these 3 problems. I want you to solve these 3 using the long method. Take this time now to pause the video. If you have any questions, go back, have a look at what we've just done together before moving on. Okay, so pause the video. Alright, welcome back. If you paused the video and you got all 3 right, well done, fantastic, let's move forward together. If not, just take this time, spend a little bit longer, have a go going back, check where you went wrong, and correct yourself before you move forward. There's no point moving forward if we're not getting things right already, okay, so that's really important. Now let's look at the short method. This is the method we all want to get to. This is kind of our final stage of multiplication. It's really, really ambitious. But it's really important that we've done the previous stages so that we have that cognitive understanding, that understanding of what's actually going on with the numbers and actually going on with our question. We don't want to fly straight to this method and perfect this because we don't actually understand what's going on if we do that. And if we ever forget one part of it, it's all just going to come tumbling down like dominoes. So we don't want to do that. We want to really understand what's going on so that when we move into the short method, we have a really solid understanding. So let's have a start. Let's have a look at the short method. Okay, short method. I've got the same question, 143 times 5. Now we are going to set it up ever so slightly different because it's short. We only need 1 bar across it, or 1 equals bar, to get our answer. But we're going to make sure we've got our units, our tens and our hundreds all at the top there because they're really important to make sure we are putting things in the right column. Remember, this is column method. We need to make sure we are doing things in columns and in the right columns. If we get something very wrong here, it is very wrong. We're going to change the whole value of our answer and the whole value of everything, and we need to make sure that does not happen. So, units, tens and hundreds at the top is very, very important to get into that habit. Now, one little tip for you, I want you to drag this bar down. Leave a column, leave a bar across there. Okay, we're going to use that in a moment, and you'll see why. Okay, so let's start with our units. Start with our smallest value, 5 times 3. So 5 times 3, 5, 10, 15, 15. 110 and 5 units. So I can put my units in because we're working out our units, but we've not solved our tens yet. So let's use this space we've just created to remember that my answer in my tens has got an extra 1. So I'm going to put my 1 across here to signify that's another 1 I need to add on in a moment. So put my 5 in, great, and I've got my 1 ready. Okay, let's look at step 2, 5 times 4. Now we know it's a 40, but in this case, because we're doing it all in the same, we're just multiplying our tens now. 5 times 4 tens is 20. We've got 20 tens, but don't forget this little one we've got before. So we've got an answer of 21 tens, okay? Or 2 hundreds and 1 10. So I'm going to put my 110 into the correct space, into my bar, in the correct column, and I'm going to move my 200 into my hundreds answer, okay? Step 3, 5 times 2. 5 times 2 is 10, but we've also got this other 2 that we need to remember. Add that back on, so my answer is 12. 12 hundredths, okay? Now we don't have a step 4, so I'm just going to put it straight into our answer. We've got nowhere else to carry it on, so we've got a 3-digit number. So 1,215, making sure I put my thousand sign back up there just for good habits. Okay, great. Let's check our answer. 1,215, that matches our long method. So we know we've done everything right. Well done, guys. Perfect. Okay, great. Now it's time for another practice. Let's use this time to have a look at these three questions, pause the video, try and use short method in order to solve them, okay? Now short method is tricky, we can make small mistakes, so let's just give you a couple of tips that are going to help you avoid those basic mistakes, okay? First tip, the most important one I think, is get those hundreds, tens and units really clear up at the top so you don't put things in the wrong column and you lay things out nice and neatly. Remember, in maths, the neater we are, the less likely we are to make mistakes. Okay, so get those columns nice and clear. Once you've done that, drop that bar down. Give yourself a spare row that you can put your carryovers into. It's going to help you avoid those small mistakes of missing a number that you've squeezed in somewhere because you've not given yourself enough space. Remember, spread your work out, make it look nice and clear. Okay, great. So pause the video now, take your time, work these questions out, and let's have a look at some answers in a moment. Alright, brilliant. Put the answers on the screen for you. Hopefully you've got the right answers. If you've not, go back, check again where you might have made your mistake, look at the last part of the video and correct any errors. If you have, well done, fantastic. 10 minutes worth of math lessons and you already got it. Beautiful, fantastic. Okay, now it's time for our recap. Let's have a little look at what we've done today. So we had a look at two methods. We looked at first the long method and then we looked at the short method. I've got them here side by side for us. Let's just remind ourselves exactly what to do from the start. First things first, we lay everything out properly. We put our hundreds, tens and units at the top so we can clearly make sure we don't get any mistakes and put things in the right value. Okay, after I've laid everything out perfectly, I can begin. And I always start with my smallest value, which in this case is a 7 times 4. Put my answer in here, 28, fantastic. Then I'm going to put 7 times 10, get that answer in there, 70. And then I'm going to do my 7 times 600, put that in there, 4,200. Beautiful. Once I've done that, I can add it all together. Gives me a grand total, 4,298. Okay, short method. So same thing, lay it up, get your units, tens, and your hundreds in there. If you've got a 4-digit, you're going to need 1,000, or if you predict your answer is going to come over 1,000, get your 1,000 there anyway, why not? And then let's start with step 1, doing our units again. But 7 times 4, 7 times 4 is 28, but we don't put 28, we put our 2 into our tens column, ready for our tens answer, and we get our unit in our answer column, 8. Step 2, 7 times 1 gives us 7, but don't forget that other 2 leaves us 9. Nothing to carry on, just 9 tens. Once you've done that, step 3, 7 times 6 is 42, nothing to add on, so just put it in there. We've got no more to work out, so we can get that straight into our answer box. Gives us a grand total again, 4,298. Our answer is the same, which means we've done it right. Well done, everybody, fantastic. We've used two different methods and we've got the exact same answer. Okay, let's just quickly discuss why we might use these two different methods and who wants to use what and when. If you're somebody that struggles a little bit with this and you're not quite sure what's going on when you're multiplying a big number, stick with the long method. It helps you to understand exactly what you're doing. You're partitioning it to solve the bigger problem. Okay, you're doing it in smaller chunks and you can see what the value of those chunks are really simply. So stay with the long method until you really understand exactly what you're doing and feel comfortable working them out with very few mistakes. Okay, but if you are someone that gets it and you've done all of that, you've done your long method, you fully understand that you're partitioning a number, you're doing it in small bits, move into your short method. It's more effective, it's quicker, you can start to move on with your multiplication more effectively, okay? Alright, that leads us nicely into what's next. Well, today we've been looking at a 3-digit number multiplied by a 1-digit number. We could simply do a 4-digit number by a 1-digit number, 5-digit number by a 1-digit number, just by adding those extra steps. It doesn't actually make it any harder, it just makes it longer. So what is next? Next becomes a 3-digit number by a 2-digit number, or a multiple digit multiplied by a multiple digit. Okay, that is a little bit harder. It's our next step, and it will probably be the next thing you're looking at either in school or in your textbook or just in your own learning journey. So search for my next video for that if that's what you're looking for, or that's where your stage is. Alright guys, please give us a huge thumbs up, massive like, and subscribe to this channel please. It's really helpful, it'll be really great. Thank you very, very much, and I hope this video has been useful to you. Yeah, peace out. Your maths hero, gone. Okay, so we are going to be looking at the basics of adding and subtracting fractions today. Now, if you've looked at multiplying fractions already, great. If not, don't worry. I personally think that looking at multiplying fractions before you're looking at adding and subtracting fractions is a good piece of advice. So check out our video on multiplying fractions if you haven't already, okay? But today we're looking at adding and subtracting fractions. So if you have looked at multiplying fractions, you will know that it's very simple. All we do is we multiply the top numbers and we multiply the bottom numbers. So if we have 3/5 multiplied by 2/4, then all we need to do is multiply the top numbers. 3 times 2 is 6. Bottom numbers, 5 times 4 is 20, giving our total of 6/20. But can we use that same trick for adding and subtracting fractions? Let's have a look. Let's have a look at a really basic fraction. Let's have a look at 1/2 add 1/2. Now we know that's going to be a whole. 1/2 a pizza and another half of a pizza is going to give you a whole pizza. Okay, so let's just see if that same tactic works for this. 1 add 1, looking at the top two numbers, equals 2. If we look at the bottom two numbers, 2 add 2 is 4. Now 2/4 or 2/4 simplified down is 1/2. 1/2 add 1/2 is 1/2. Okay, we've done something wrong. We cannot use this same trick. Okay, let's see why this does not work. We have a very important rule in mathematics, and that rule is something called the order of operations. Okay, now what that says in this rule is that we need to always multiply and divide before we add and subtract in any problem. And because fractions are just division problems, we can't do the addition before we do the division part, okay? So we can't add the top numbers and then the bottom numbers because then we're skipping out the division part, okay? And we can't do that, okay? So luckily we do have another trick. This is your secret tip. Don't tell anyone. Okay, but before I can tell you the trick, we need to look at a fraction and what it's made up of, okay? We have a numerator at the top and a denominator at the bottom. Our denominator at the bottom just is the name of our fraction. It's 1/5, 3/5, 5/5. It's a fifth. The value is fifth, okay? The numerator is how many fifths, the number, the quantity, how many fifths we have. 1/5, 3/5, 4/5. How many of that value do we have? Once we can understand that, once we can start to think of a numerator as the number, the volume, the quantity of the fractions we have, similar to saying 1 donkey, 3 donkeys, 5 donkeys. It's just the name of the fraction. So if we think of it like that, the numerator is how many we have and the denominator is what the name is, then we can just simply add the numerators or subtract the numerators to give us our new value. Okay, so if we look at that with our halves again, we have 1/2 add 1/2. So we're going to add our numerators. 1 add 1 is 2. But we're going to keep our denominator, the name, the same because the value of our fractions haven't changed. Okay, so 1/2 add 1/2 is 2 at the top, 2 at the bottom is a whole. Okay, and then that's right. 1/2 add 1/2 is a whole. Fantastic. Let's see another example of this trick. If we had 3/15 add 4/15, we could have 3 elephants, add 4 elephants. 3 add 4 is 7. The name of the fraction hasn't changed, it's a 15th, so we have 7/15. Simple. And the good news, that works with subtraction as well. Let's have a look. If we have 5/10, subtract 2/10, what am I doing? I'm taking 2 away from the 5. 5 subtract 2 is 3. We haven't changed the value of the fraction, so we have 3/10. Simple. How easy could this be? Well, let's just pause a second. Let's not get carried away. Let's not think we are Albert Einstein all of a sudden, okay? We have got a little problem. All of our denominators are the same in these examples, okay? We had 1/2 add 1/2, 3/15 add 4/15, 5/10 take away or subtract 2/10. Now the name for this is like fractions. They are alike. We have 1/2 add 1/2. We had 3/15 add 4/15. They are alike. If the denominators are the same, we call them like fractions. And if they are not alike, we call them unlike fractions. Okay, and we need a solution to adding unlike fractions. Well, don't worry, I would never let you down like that. There is a solution. We can manipulate the look of our fraction, give ourselves an equivalent fraction, but getting the same denominators, okay? But we're going to look at that in a different video. If you are ready for that, check out our video on adding and subtracting, unlike fractions, and then we're going to learn all about how to create and transform our fractions into equal but different looking fractions with different numbers so that we can add them and subtract them. Hope this video has been helpful for you guys. Like and subscribe to the channel for weekly videos going all the way through the English curriculum, and got fun and exciting riddles and challenges as well. So please give us a big thumbs up and a like if you've enjoyed this video. For now, away. Okay, so what do we know so far? Well, we've been very used to looking at the place value chart when looking at numbers. And we've learned things like units, tens, hundreds, thousands, even 10,000 and 100,000s, okay? And we could go much further. What we've learned is that every time we go along one column, we are multiplying that value by 10. So a 1 in the units column represents 1, but a 1 in the tens column represents 10. And that carries on the whole way down. We've also learned that when we do a calculation involving addition and subtraction, we always start from our smallest value, which so far has just been units. So let's introduce decimals. Now, decimals are a fraction. They are a fraction of a whole. So therefore they are going to be smaller than a unit, okay? How much smaller? Well, we just carry that same pattern along. Every time we go into the next place value column, we are going to be getting 10 times smaller. So the first place value column for a decimal is tenths, because it is worth 1/10 of the whole. So the pattern for what our place value chart would look like would start with tenths, then it would move to hundreds, because that's 10 times smaller, then thousands, and carrying on the same way. The length that our place value chart can go is infinite. Okay, so let's have a question. Let's have 32.5 add 15.2. Now remember, addition is commutative. It doesn't matter which way around we put these in our questions. Okay, so it could be 32.5 add 15.2 or 15.2 add 32.5. It doesn't matter at the moment, okay, because this is addition. Not the same rule for subtraction, but we'll get there in a minute. Okay, so the good news is we are going to use the same structure, the same columns that we're used to in addition. However, we now have another column that we've not seen before. We now have the tenths column. Now I hear you say, wait, I'm confused. You've always told us to make sure we line our things up with the units. Do we still do that in this case? The answer is yes, but we also look at our decimals. The decimals will always be there. So even if we have a number like 52, just because there's not a decimal after it doesn't mean it's not there. We could have 52.00 and those zeros could go on forever. Okay, so we can always guarantee that the decimal point will be there. Okay, so we're going to use that to line up our numbers and make sure that we put all our decimals on top of each other. If you do that, you're going to avoid all those silly mistakes of putting things in the wrong place and adding the wrong values together. Okay, so very, very good tip. Make sure you concentrate on your decimals and line them up perfectly. Okay, fantastic. Now we're good to start. Okay, now I want to share another good tip with you, because another small mistake that I've seen hundreds of times is when people forget to put the decimal point in their answer. So I suggest at this point we know where it's going to be. It's going to carry on that same column. So let's put the decimal point in now before we start. Okay, good. Now we're ready to start. Now we always start at our smallest value. Now that has usually been units, but in this case we're going to look at the tenths column because that is our smallest value. So I've got 5/10 added to 2/10, leaves me 7/10. Perfect. Then in my units column, I've got 2 add 5, again gives me 7, and in my tens column, I've got 3 and a 1, which gives me 4. My answer is 47.7. Fantastic. Now, this was a green chili because we had the same amount of decimal places after our decimal point. You can see that we only had one number after the decimal point in 32.5 and only one number after the decimal point in 15.2. What happens if we have different amounts of decimals? Well, let's have a look. Let's check out our red chili challenge. So sometimes we can get questions where the amount of numbers after the decimal are different. Take for example, 31.5 add 7.26. We now have a number in the hundredths column. I've got a 6. Okay? So here is where that top tip of lining up our decimals really comes into its own. If I put my decimals in line with one another, then everything else falls in around it. I have 31.5 plus 7.26. But I've got a couple of gaps. Now in addition, that's not really that important, but it's really important for subtraction, so let's understand what we can do. 31.5 holds the same value and is exactly the same as saying 31.50. That 0 doesn't change the value of the number, but it's called a placeholder. We can put it there so that we can have the same amount of digits in both of our numbers. So I've got 31.50 add, yeah, you guessed it, 07.26. Okay, so now I've got the same amount of digits in both of my numbers. Now it's really important to understand what these placeholders are, because we're not just putting a random number in there, we're putting a 0, something that doesn't hold any value. Okay, adding a 0 to the beginning or end of a number doesn't change it at all. Okay, so that's really important to understand. Now again, we're just going to solve this from the smallest value, which in this case is hundredths. So 0 add 6 is 6, 5 add 2 is 7, 1 add the 7 is 8, and 3 add the 0 is 3, leaving me 38.76. Okay, well done. Well, that is about as hard as decimals can get. In addition, we can have much bigger ones, but it's not going to get any harder, it's just going to get longer. Okay, so that's really good. Well done. So, let's check out subtraction. Okay, so let's have a look at 38.6 subtract 5.53. Now the good news is, we're just going to use exactly the same idea of laying everything out in columns. That's the good news. The bad news is, we've got to be ultra careful here, okay, because subtraction is not commutative. If the question says 38.6 subtract 5.53, we have to do it that way around, and the 38.6 will go at the top, subtract 5.53 will go underneath. Okay, it's not commutative, it will be a completely different answer if we change them around. And the second thing, and the one that everybody makes mistakes on at some point, is forgetting to put in our placeholders. And let's see why that's really important, okay? So, if I don't put any placeholders and I put 38.6, subtract 5.53, I might be inclined, when I see the 3, I might think, well, there's nothing there to subtract. But that's not what the question was asking me. I'm subtracting this number from the top number, so I've got to be subtracting the 3 from something. Even though there's nothing there, what do we now know? That's right, there is a 0, so we can put that there. And that's really important because 0 subtract 3 is very different to 3 subtract 0. Now can we take 3 away from nothing? No, so we need to borrow from next door, just like we would do in any of the subtraction question. So, borrow from next door, take the 6 to a 5, bring the 1 across, 10 subtract 3 is 7, 5 subtract 5 is 0, 8 subtract 5 is 3, and 3, don't forget the other placeholder, 3 subtract the 0 is 3, giving me an answer of 33.07. So I'm going to say that again, it's really important to use your placeholders in subtraction, don't forget. Okay, now in a minute I'm going to let you have a go at solving some questions yourself, but first let's do a little review, okay? So, first things first, remember that decimals are fractions, they are smaller than a unit, so therefore they have a smaller value. That's the first thing to be really clear on. Next thing, we're going to line up our numbers as normal, except we're going to be focusing on using the decimal point to align our numbers. Third, placeholders are essential to put in there to avoid making small mistakes. And the last thing we need to review is we always start from our smallest value, which now might be anything from tenths to millionths or anything like that. Okay, so I'm going to put some questions on the board behind me. 1, 2, 3, 4. And it's your job now to try and solve them. I've got 2 addition and 2 subtraction. Good luck. If you get them all right, fantastic. You're ready for our next video. If you don't worry. Stop, go back, look at where you might have made a mistake and correct yourself. Okay, don't move on until you're completely ready. So I'm going to disappear, and this is a good time for you to press pause on the video, take some time and see how you get on, okay? Okay, welcome back. Hopefully you got those all right. If you did, fantastic. If not, like I say, go back and have a little look at where you might have made a mistake. So let's look at what's next. Today we've been looking at adding and subtracting decimals. Next video we're going to be looking at multiplying decimals. So multiplying, for example, 5.3 multiplied by 15. Okay, so that's going to be our next video. Check it out if you want to. Thank you very much for watching this video. Really appreciate it. Like and subscribe to the channel, guys. Really helpful. Thanks very much. But for now, Maths Hero gone. So, what is perimeter? Well, perimeter is the distance around a shape. And distance is just a one-dimensional quantity that's measured in things like centimetres, metres, inches, and kilometres, and all different areas of measurement. So therefore, perimeter is also a 1D quantity that's measured with these things like centimetres and inches, metres, and kilometres. Let's have a look at an example. Let's have a look at a square. Now we know that a square has equal sides. So if one length is 4 centimetres, we know that all lengths must be 4 centimetres. So if we measure this, we've got 4 centimetres, add 4 centimetres, add 4 centimetres, and add 4 centimetres. Gives us a grand total of 16 centimetres. That's our perimeter. It's as simple as that. All we've got to do is measure around the outside of the shape. But stop, what do I mean exactly by that? Because there are many ways of measuring around a shape. We could draw a line around the square, that's going to have one measurement, but I could draw a much bigger shape all the way around our square, and that's going to have a different measurement. So we need a rule, and the rule is that we measure the shortest possible measurement. And in all cases, that is going to be measuring the lines themselves. So in this case, 4 add 4 add 4 add 4 gives us 16. But 16 what? That's right, centimetres. The units of measurement are very important. It's not elephants or cars, it's centimetres that we're measuring in here. Could have been miles, could have been inches, or any other form of measurement, but in this case it's centimetres. And it's very important to say that because a square that's 16 centimetres in perimeter is very different to a square that's a mile or 16 miles in perimeter. Okay, so very, very important. We always put our units of measurement. We could go very wrong. So one way to think about the measurement is that we are going to be walking on the lines of our shape, and the length that we walk is our perimeter. So if we start here in this corner and I walk all the way around the square, that gives me my perimeter, okay? Or another way of looking at it is if we take one of the corners and we unravel the corner and we stretch our line out into a straight line, given it its one-dimensional property, which is why it's got the reference to the one dimension, then the length of that line is the length of our perimeter. Okay, so it's just like measuring the entire length around the shape. Great, so now we know what perimeter is. How do we measure perimeter of geometric shapes? Now some shapes like circles or hearts or clouds are going to be very difficult to measure the perimeter of because they're not straight lines, or they have areas that are not straight lines, okay? And actually in our next video we're going to be looking at how to measure the perimeter of a circle, but for now we're going to be looking at polygons. Polygons are shapes with straight lines, okay? So they're much easier to measure the perimeter, and that's where we're going to start. And it's pretty easy. If we are given the measurements of the sides, or the lengths of each side, then we can just simply add them up. Be careful to make sure that they're all in the same units, and we're not adding a metre to a centimetre or something like that. But in general, all we need to do is add it up to get to our perimeter. So let's look at a few examples. Let's have a look at this triangle with sides of 3, 4 and 5 centimetres. So in order to find the perimeter, all I'm going to do is add 3, add 4, which gives me 7, add the 5, which gives me 12. So the perimeter of this triangle is 12, that's right, don't forget it, centimetres. Very important to make sure we use that units. Now let's look at another example. Let's look at this rectangle. Now this rectangle has sides of 5 centimetres and a top and bottom length of 10 centimetres. Okay, so it doesn't matter which order we start it in because we're going to be adding them all together, and we know that addition is commutative. It doesn't matter which way around we put them. So we can start anywhere, and I'm going to choose to start with the tens. I'm going to add my two tens together, which gives me 20, add my two fives together, which gives me 10, 20, add 10 equals 30 centimetres. Very good. Okay, cool, another example done. Let's have a little look at something a little bit harder. Let's have a look at an orange chili, okay? An orange chili challenge. So, sometimes you won't be given all the measurements, and you've got to infer and decide what you think those measurements are based on the information you've already got, okay? So let's look at that same rectangle, and let's take away some of those measurements. So if we have a top side of 10 centimetres, we know that that bottom length is also going to be You guessed it, 10 centimeters. Okay, so we could put that in if they hadn't given it to us. And again, with the 5 centimeters, if one of the lengths is 5 centimeters, we know that the opposite length will be 5 centimeters based on the characteristics of a rectangle. Okay, so even though they weren't given to us in this example, we could infer and we could deduce those measurements ourselves using skills and using knowledge of rectangles. Okay, so that's an orange chili challenge. Now another example of an orange chili challenge, in my opinion, would be looking at regular shapes. Because regular shapes, if we know about geometry and we know about shapes already, regular shapes have two qualities which are the same. They're going to have the same angles and, importantly for us, they're going to have the same length side. So you might see sometimes on a test or on a question that you're given, a question where it has, tell me the perimeter of this shape, for example this pentagon which has length of 5 centimeters, but it's not giving you the other length. But it said in the question, this regular pentagon. So again, we're going to use our information of shapes and understanding what we know about the word regular, that length therefore is the same length for all the lengths on that shape. So we can use that 5 centimeters and add it to another 5 centimeters for the second line, another 5 centimeters for the third line, another 5 centimeters for the fourth line, and another 5 centimeters for the last and the fifth line. Okay, so we're going to do 5, add 5, add 5, add 5, add 5. Okay, a little bit lengthy. We could learn at this point that we could also use multiplication, because remember, multiplication is just repeated addition, which is what we just did then. We repeated the same addition. So instead of doing 5 add 5 add 5 add 5 add 5, we could simply do 5 times 5 because there's 5 lengths. Okay, great. Let's have a look at a red chili challenge, something even harder than that. So I'm sure you've seen shapes like this. This is called an irregular shape or a compound shape, depending on what your question is asking you. Now, problems like this come up all the time, okay? You're going to see this very often in your math and in the real world. You might have measurements that you can see, but you might have missing measurements that you cannot. So you're going to have to use the information you've already got to help solve what you don't know already. Okay, so let's have a little look at this a bit closer. Let's take these two vertical lines, and at the minute I've got a 4 and a 3 centimeters. So my missing number on the other side, it makes sense that if I just bring my two vertical lines across, then therefore that gives me that whole length. So this missing number is just the combination of the 4 and the 3. Adding 3 and 4 together gives me 7, so therefore that missing length must be 7 centimeters. Okay, so I've used that information on the other side to help me solve that missing number. Let's have a look at the horizontal. I've got a 5 and a 3. So on my horizontals, I've got 5 and a 3. If I bring them down to my missing number, so therefore that missing number is going to be again the combination of those two numbers. 5 add 3 is 8, giving me a total of 8 centimeters. So this red chili challenge is as hard as it's going to get with polygons really. We've got mixed numbers, we've got the understanding of missing numbers, we've got the understanding of what perimeter means, and we've also, as a bit of a bonus, got the understanding of we could use multiplication sometimes, rather than just adding and adding and adding if the number is the same, for example, in a regular shape. Okay, so I'm going to put some examples on the board for you here, have a little look, try and solve them. I want an answer for all 5 please in the comments section before you move on. If you get all 5, great, fantastic, move on to our next video. If you don't, stop, have a little look, go back in this video, see where you might have made a mistake and correct your errors. There's no point moving on if we're still making errors at this point. So it's really important to address them and get them ironed out right now, okay? Okay, if you got those right, that brings us to the end of the video, so well done for that. On our next video, we're going to be looking at how to work out the perimeter of circles. It's a bit challenging, so make sure we're really comfortable with this before we move on to that. So if you want to check that out, like and subscribe to the channel, guys. Thank you very much, but for now, I am gone.